Hey, fourth graders, I'm sure you're all so excited and you look just like this because you're ready to start lesson 3-6. And in lesson 3-6, you're going to learn how to multiply with mixed numbers. You're also going to learn how to predict the outcome of a multiplication problem when it has mixed numbers. And that means that you'll be able to tell just by looking at a problem whether or not the answer is going to be greater than one factor or of both factors. The great news about today's lesson is you don't have to be an Einstein to do this. In fact, you already know how to do most of the steps that are required in order for you to multiply fractions and mixed numbers. Let's quickly review some of the things you've learned before. If you were given two problems such as the ones on the screen, in the first problem, you would take 5 times 3, we multiply our numerators, and we get 15, and the two denominators, the product would be 56, so our final answer is going to be 15/56. And I look at that and I know that I cannot reduce that at all, so it's a final answer. In a problem such as the one below that, we have a fraction times a whole number. So I can turn that whole number into a fraction over 1, and I end up with 16/17. And again, I know that I cannot reduce that, so that is the final outcome, the final product. You've also seen problems like these three. We could go ahead and multiply those just the way we did before, and we end up with 36/100 and 42/49 and 28/420. But when you look at those, there's a lot of simplifying that has to be done. So I can start off by simply simplifying the first step that I know. Like I know I can divide both those numbers by 2, and then I get 18/50ths. And then, wow, I can simplify again. So now I have to go into 9/25ths. And if we jump down to the bottom problem, I can look at that and try to think of the largest number I know can go into it. So I know that 7 can go into 28 4 times, and well, 7 go into 42, so it must be able to go into 420, and that goes in 6 times, but that would really be 60, and wow, there's a lot of steps there. Not to mention the steps it took for me to find out that the product of 35 and 12 is 420. So instead of doing all that work, what you learned to do in previous videos was to try to cross-cancel and simplify before you multiply. So when we cross-cancel, what we're trying to do is look to see if the numerator of one fraction can divide the denominator of the other, and vice versa, if the denominator of one can divide the numerator of the other. And in the first problem, we start with 3/4. I'm going to look at the 3 as the numerator and see across the problem, can 3 divide 25? No, it can't, so there's no simplifying to be done there. But 4 can divide 12. 4 goes into itself 1 time, and it goes into 12 3 times. So that gives me 2 new numbers to multiply. 3 times 3 is 9, and 1 times 25 is 25. And I already have the simplified product. I don't have to do extra work at the end. And I can do the same on the problem that's underneath that, even when it's a whole number. I can go across and decide, can 6 divide 1 or 1 divide 6? Well, yes, 1 can divide 6, but that won't change anything, so nothing changes there. Can 49 divide 7? No, but 7 can divide 49, so 7 goes into 7 1 time, and into 49 7 times. With my 2 new numerators and denominators, I'll multiply out, and I get 6/7. Again, already simplified to its lowest terms. And in the bottom problem, I start off and I'm looking at 4 and 12. Can 4 divide 12? Yes, it can. 4 goes into 4 once and into 12 3 times. Can 7 go into 35? Yeah, it can. So 7 goes into 7 1 time, and it goes into 35 5 times. And now I have 1/15. And if you remember before, I had an original product of 4/60, which wasn't an answer in its lowest terms. It still could be simplified. I could have done that by going and changing that to 2/30ths, but then I'd still have to simplify again down to 1/15th. Now, you might have been able to jump from here to there, but still, a lot of extra work when it's a lot simpler to divide these small numbers and try to multiply out and get a large product. You've also come across problems like this one, and at first glance you might just think we can simplify in the same way we have before, and you're partially right. So I can see that 6 can go into 12. 6 can divide 12. 6 is a factor of it. So 6 does go into 6 once, and it goes into 12 twice. But now I'm left with these two. The problem with those two values is that one is not a factor of the other. 15 can't go into 25, and 25 can't go into 15. But that doesn't mean I have to skip the step of simplifying. Instead, now all I have to do is think of, is there a number that divides 15 and 25? And that is 5. 15 can be divided by 5. It goes in 3 times. 25 can also be divided by 5. 25 divided by 5 is 5. So even when one number is not a factor of the other, I can still simplify if they have a common factor. So I end up with 3/10. Here's one more example. In this problem, I look across at 7 and 36. 7 is not a factor of 36. 36 isn't a factor of 7. And there isn't a number that will go equally into both 7 and 36. So I'm stuck there. But now I can go across here. And I look at 18 and 24. And I might think that, oh, I'm stuck again, and I'm going to have to end up multiplying 24 and 36. But that isn't the case. If I look at 18 and 24, although they aren't factors of each other, they have a common factor. 18 can be divided by 6, and so can 24. I'm looking for the greatest common factor here. So yes, 2 could go into both of those numbers, but better to use the greatest common factor. There'll be less simplifying and easier multiplying to do later. So 6 goes into 18 3 times. 6 goes into 24 4 times. And now all I have left to multiply is 7 times 3, which is 21. And, well, I will still have to do 4 times 36, but that's still a lot easier than having to figure out 24 times 36. And 4 times 36 is 144. Right now you might be thinking, this stinks, Mrs. Bros. I'm done with review. I'm ready to move on to something new. Well, guess what? It's time. Multiplying with mixed numbers is as easy as these 4 steps. Step 1. Turn any mixed numbers into fractions. That's simple enough. You learned how to do that way back in Unit 1. Step 2. Cross-cancel if possible. Something you learned just a few lessons ago. Step 3. Multiply the numerators and denominators that you now have. That's something you just learned how to do. Nothing new again. And of course, at the very end, double check to see if you need to simplify or reduce. Here's a problem we can try the steps with. So step 1, turn any mixed numbers into fractions. There's a mixed number. To turn that into a fraction, that's going to become 4/3. And now I have 5/6 times 4/3. Step 2, cross cancel if possible. Looking across at 5 and 3, 5 isn't a factor of 3, 3 is not a factor of 5, and only common factor is 1. Nothing to be done there. Now I look at 4 and 6. 4 and 6 aren't factors of each other at all, but they have a common factor, and their greatest common factor is 2. So 2 goes into 4 twice, 2 goes into 6 3 times. Step 3, multiply the numerators and denominators. 5 times 2 is 10. 3 times 3 is 9. Step 4, simplify and reduce as needed. Well, this number is not simplified. It is still a fraction greater than 1. So I turn that into 1 and 1/9. And now I'm done. In this example, we have a mixed number times a whole number. Well, Let's try the steps again. Let's turn any mixed numbers into fractions. So 3 2/5 is going to become 17/5. 3 times 5 is 15, plus 2 is 17. And 7, that becomes 7/1. Now I check to see, can I cross cancel? There is no number that divides 5 and 7, and they can't divide each other. I can't do anything there. And I look at 17 and 1. Nope, nothing I can cross cancel. Well, we tried this step, but it looks like we're going to have to go ahead and multiply those numbers anyway. That means our product is going to be 119/5. Well, now I have to simplify and reduce. Step 4. So I have to divide 119, or 119, pardon the and there, 119 by 5. And that will bring us to 23 4/5. Now, you won't always have that situation where you end up not being able to cross cancel when it's a whole number, but sometimes you will. You just have to check all 4 steps each time. In this last example, there are 2 mixed numbers. Time to do our steps. First, turning our mixed numbers into fractions. 1 2/7 becomes, well, 1 times 7 is 7, plus 2 is 9, 9/7. 2 2/3, 2 times 3 is going to be 6, plus 2 is 8/3. So now I look across and see, can I cross cancel? Step 2. Lo and behold, 3 is a factor of 3 and 9. So 3 goes into 3 once and into 9 3 times. Then I have 7 and 8 left. 7 and 8 cannot divide each other, and they have no common factors besides 1, so they'll stay the same. Now I have 3 times 8 is 24/7. Step 4 is simplify and reduce as needed. Well, 7 can go into 24 3 times, and that would give me 3 left over. 24 sevenths becomes 3 and 3/7. Your turn to try, but I'm not worried. I'm sure you guys are going to come out just like a champ. Remember your 4 steps. Turn mixed numbers into fractions. Cross cancel as needed. Multiply your numerators and denominators. And simplify and reduce if you need to at the end. Pause your video now and give these a shot. Okay, let's go over your work. 3/7 times 2 1/2 becomes 3/7 times 5/2. I look to see if I can cross cancel. Nope, there is no common factors between the numbers and the fractions. So now I have 15/14. And 15/14 is now step 4. I simplify and reduce. That becomes 1 and 1/14. The next problem, both of the factors need to turn into fractions greater than 1. So 2 2/3 is going to become 8/3 times 4 1/5, that becomes 21/5. And I look across and I find that I cannot cross cancel 8 and 5. They have no common factors. But 3 and 21 do. 3 goes into itself once, into 21 7 times. I now have 8 times 7, so I'm on step 3, multiplying numerators. 56, and my new denominators would be fifths. 5 can go into 56 11 times, with 1 left over. 11 1/5. And for the final problem, 2 3/4, well, that is 11/4 times 12/1. Step 2 would be to check if I can cross cancel. I can divide 4 by itself, and that's 3, and 4 goes, I'm sorry, 4 divided by itself is not 3. 4 divided by itself is 1, and 4 divided into 12 is 3. And so now I am step 3, I'm multiplying my numerators, and that gives me 33. My denominator is 1, so step 4, simplifying, that would be just 33. Now we're going to take a minute to go ahead and practice predicting outcomes when we're multiplying mixed numbers. We'll quickly review what we learned about predicting outcomes from our earlier lessons. So we have 2/3 of 6 and 2/3 of 6/7. In the first example, we can predict that the outcome or the product of 2/3 of 6, without even getting an answer, we know that that's going to be greater than 2/3, but less than 6. Because whenever we are multiplying a fraction and a whole number, the answer is always going to be more than the fraction, but less than the whole number. That's because when we look at 2/3 times 6, that's saying 2/3 of 6. So we know we're finding part of 6. Well, part of 6 has to be less than 6. And 2/3 times 6, however, also means 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 and one more. It means 2/3 being repeated 6 times. Well, if I have 2/3 repeating 6 times, it's going to be greater than 2/3 itself. Then in the next example, we have a fraction times a fraction. Well, this is a part of a whole. This is another part. So whenever we multiply two fractions, we know that the product is going to be less than both of the factors. Why is that? Well, because if we think of it as 2/3 of 6/7, we are finding part of 6/7, and part of 6/7 will have to be less than 6/7. But if we flipped it around, 6/7 of 2/3, well, that's still finding part of 2/3. So part of 2/3 will also be less than 2/3. So the answer of a multiplication problem involving two fractions less than 1 will be that the answer will be less than both fractions. So now we have to apply that to some situations with mixed numbers. Here's 3 new problems, but these 3 all involve at least one mixed number. Now I want you to just take a moment, think about what you know already about multiplying fractions in whole numbers, and multiplying two whole numbers, and see if you can figure out or make a rule for what will happen when we multiply mixed numbers in each of these situations. You may have been able to see that the first situation is very similar to what we would see if this were 2/5 of another whole number, or a whole number. So for example, 2. What we have is a fraction, something less than 1, times something that is greater than 1. 1.5 is greater than 1, just like 2 is greater than 1. So anytime you're multiplying a fraction by something that is greater than 1, the product's going to be less than the mixed number, or less than the part that's greater than 1, but it's going to be greater than the fraction itself. In the situation we have 2/5 of 1.5 will be less than 1.5. We're finding part of 1.5. But when we flip it around, 2/5 of 1.5 also means that 2/5 is being repeated 1.5 times. It's 2/5 and then a half of 2/5 more. So that would have to be more than 2/5. In the bottom two situations, you may have also been able to think of those in the way you would think of a simple problem, such as 2 times 3. In a problem like that, we have two values that are greater than 1. Anytime you have two numbers being multiplied that are greater than 1, the answer is going to be greater than both factors. 2 times 3 is 6. 6 is greater than 2. 6 is greater than 3. And that's because multiplication means the same as repeat addition. So 2 times 3 means 2 plus 2 plus 2, but it also means 3 plus 3. It means the factors are being repeated a certain amount of times. Well, although we have mixed numbers and these two problems, they still represent values that are greater than 1. 1 and an eighth is greater than 1. 2 and a fourth, 3 and 2/3, they're greater than 1. So in the second situation, where we have a mixed number times a whole number, the answer is going to be, or the product is going to be greater than both factors. So it'll be greater than the mixed number and greater than the whole number, because this problem means that 1 and an eighth is being repeated 2 times. So 1 and an eighth repeated will have to be more than 1 and an eighth by itself. It also means 2 is being repeated 1 and an eighth times. So it is 2 plus an eighth of 2 more. So we're going to see an answer that is greater than both factors. And that's the exact same situation that's going to happen when we multiply two mixed numbers. Mixed numbers are values greater than 1. So we may not be able to predict the exact answer, but we know the answer is going to have to be greater than 2 and a fourth and greater than 3 and 2/3. Anytime we multiply two values greater than 1, the outcome will be greater than both factors. 2 and a fourth is being repeated 3 times and 2/3 of a time more. 3 and 2/3 is being repeated 2 times and a fourth of a time more. It only would make sense that the product would be greater than both. Now, I know that may not have been 100% clear yet. We're still working on these generalizations. So please don't worry. We're going to continue looking at these and practicing this throughout the rest of the unit. I'll see you guys tomorrow, and make sure you have any questions ready so that Mr. Hall and I can answer them. Have a great night.